Good day, viewers. Welcome to another lesson. Again, it's your presenter Khalid Jallo, and we are going to look at our third lesson on the grade 8 rather. We are going to look at the properties of tetrahedron and a sphere. Properties of tetrahedron and a sphere. Now, we'll look at the properties of tetrahedron based on the number of sides that they have, number of angles that they have, number of vertices that they have, and so on. That is what we are going to look at on the tetrahedrons, and why are they specifically called tetrahedrons, and so on. We are also going to look at spheres. We are going to find out what are some of the properties that a sphere has, the number of sides that it has, if it has any, the number of faces that it has, if it has any, the number of vertices that it has, if it has any, and what constitutes a sphere, how do we recognize a sphere, and so on. That is what we are going to look at in today's lesson. And to start with, we are going to look at tetrahedrons. We are going to look at tetrahedrons. We say a tetrahedron is a pyramid and all its faces are equilateral triangles. A tetrahedron is a pyramid and all its faces are equilateral triangles. A tetrahedron therefore has all its edges equal in length. Now, what is a tetrahedron? A tetrahedron is a pyramid. It's a pyramid and all its faces are equilateral triangles. That is the specific property that it has. All its faces are equilateral triangles. That is to say, a tetrahedron, this is an example of a tetrahedron. It has how many faces? We'll come to know how many faces does it have. But what is important at this point is the fact that all the faces are equilateral triangles. What that simply means that is the length of each face, the length of the faces are equal. That is, where two faces meet, they will form an edge. So it means all the edges that are in a tetrahedron are what? Are equal. So all each face here on the tetrahedron, they are all equilateral triangles. It has the shape of an equilateral triangle. And by definition, we say equilateral triangles are triangles that have all their sides equal. So when we look at this face here and we call it an equilateral triangle, what we are saying technically is that all the sides of this face are equal. And we look at another face here, all the sides of this other face are also equal. When we look at this other face as well, all the sides of the face are equal. That goes to all the sides in the tetrahedron. So you can see some of the pictures that we have here. They indicate that they are all tetrahedrons. Like for instance here, if you look at the shape, although that is not a straight line, let me try to have a straight line there. Let me try to have a straight line here. Good. Now, if you look at this straight line is just the line when we have the shape like this. This other edge here is what I am trying to demonstrate there. So maybe the line is too bright. Maybe the line is too bright. I want to make sure it is a very thin line, or I can use broken lines. That is to show that the line is on the other side. So you will see that this side here is just one face, and this face that you are not seeing, which is on the other side here, is another face, and this face on this side is another face, and the base of the tetrahedron is also another face. Again, if you look at this one, it is in this form. I can say it is in this form. The face that you are seeing here is here. The face that you are seeing here is here. The face that you are seeing here is here, and the face that you are not seeing at the back is this other face. So you can see that they all have the same number of faces. But what is important in knowing what is a tetrahedron is the fact that all its faces are equilateral triangles, and therefore you can conclude that edges are the same in length. All the edges of a tetrahedron are the same in length. Now, first of all, what is an edge? An edge in three-dimensional shapes or in solid shapes, it is the point where the two faces meet. Whenever two faces meet, they form what is called an edge. Whenever, let's say, this face and this face, they meet at this point, and where they meet is referred to as an edge. So since a tetrahedron has all its faces equal to an equilateral triangle, it means all its edges also are going to be equal, because in equilateral triangles all the sides are equal. So we are going to talk more on the edges of a tetrahedron. We're going to talk more on the faces of a tetrahedron, and also we'll talk about the vertex of tetrahedrons. Like when we talk about the vertex, it is where three or more faces meet or three or more edges meet. Like in this case, this side, here is a face, here is another face, and here we have the third face. Now here we agree that three faces meet, and where they all meet is what we refer to as the vertex or the vertices. Also, if you look at it on the side of edges, is where three or more edges meet. Like here is one edge, here is another edge, and here is the third edge. Now where they all meet is referred to as the vertex. So we are going to find out how many faces, that is equal faces, because we know that all the faces are equilateral triangles. It means all the faces are equal. We'll find out how many equal faces do they have. We'll also find out how many equal edges do they have, because they are all equilateral triangles. And also we'll look at how many vertices do they have. That is where three or more faces meet, or three or more vertices meet. We go and straight to doing that. It's a basic properties of tetrahedron. Basic properties of tetrahedron. Remember, this is the tetrahedron. Maybe it is given to you in this form, where the side here is this side, here is what we have here, here is what we have here, and the side that you are not seeing is this other side. So that is a tetrahedron. Now we want to know the number of faces that that a tetrahedron has, the number of edges that a tetrahedron have, and the number of vertices that a tetrahedron have. So that is going to help us that whenever we come across with objects in the environment, we can be able to classify them to be tetrahedrons. We need to look at these basic properties. That is the number of faces that it has, the number of edges that it has, and the number of vertices that it has. Starting with the number of faces that it has. Here is one object that we can classify as a tetrahedron. One object that we can classify as a tetrahedron. So we want to know how many faces does the object have. So we're going to label the faces in order to determine how many faces does it have. Remember, it has a face in a shape of an equilateral triangle. That means that all the faces are equal. So the number of faces that we have, we should also put into consideration that all the faces are equal. That is why it is referred to as a tetrahedron. Now we count the number of faces that the figure have. That is 1. And here we have another face, 2. And here we have another face, 3. Here we have another face, 4. Is that all? Is that all? Is that all? I think we have marked all the faces. That simply means that this tetrahedron has 4 faces. It has 4 faces. We have 1, 2, 3, and 4. So tetrahedrons have 4 faces. Not only 4 faces, but 4 equal faces. They have 4 equal faces. Tetrahedrons have 4 equal faces. 4 equal faces. Tetrahedrons have 4 equal faces. From the number of faces, we move to the number of edges. You move to the number of edges. That is how many edges does a tetrahedron have? How many edges does a tetrahedron have? Since they have 4 equal faces, it means all the edges also have to be equal. Since the faces are equal, it means all the edges are equal. The faces are equal in the sense that each face represents a equilateral triangle. Each face represents an equilateral triangle. So thus we have 4 equal faces. Then we'll confirm how many edges does it have. How many edges does a tetrahedron have? Now the edges is where the 2 faces meet. An edge is formed when 2 faces meet. So between phase 1 and phase 2 we have an edge. Between phase 2 and phase 4 we have another edge. Between phase 1 and phase 4 we have another edge. Between phase 2 and phase 3 we have another edge. Is that all? Between phase 3 and phase 4 we have another edge. Is that all? Between phase 2 and phase 3 we have another edge. Okay. So is that all? Yes. So let's count how many edges do we have. We have 1, 2, 3, 4, 5, 6. So we have 6 what? 6 edges. We have 6 edges. We said an edge is the point where the 2 faces meet is referred to as an edge. So when we count the number of edges that a tetrahedron have, we realize that it has 6 edges. Remember, the edges also, there are 6 equal edges. 6 equal edges. Six equal edges. Tetrahedrons have 6 equal edges. They have 4 equal faces, 6 equal edges. From the edges, you move to the number of vertices that they have. Now we say a vertex is a point in a solid shape where 3 or more faces meet or 3 or more edges meet. That is what we refer to as a vertex. So in this case, we are going to count also how many vertices does the tetrahedron have, so that we can confirm the number of vertices that they have. So we use the one that we have here, where the 3 faces meet. Here is a vertex. Here we have another one. Here we have another one. And there we have another one. So how many vertices does it have? Here we have 1. This is one vertex. Here we have 2. It's another one. There we have 3. This is another one. We have 4. 4. Is that all? Is that all? Yes. That is all. So we can also conclude that it has 4 vertices. So in general, whenever we are looking for the properties of a tetrahedron, here are the 3 basic properties that we need to look at. Number 1 is the number of faces. It should have 4 equal faces. It should have 4 equal faces, and each face should be in the form of an equilateral triangle. It should have the shape of an equilateral triangles, and we know equilateral triangles are triangles that have all their sides equal. Again, if you come to the number of edges, you should have 6 equal edges. 6 equal edges. They should have 6 equal edges, and also they should have 4 vertices. They should have 4 vertices. These are the basic properties that you should look for whenever you want to classify an object that you find in the environment as a tetrahedron. So you move on to the next one. We have a sphere. we have a sphere. Now, what is a sphere? A sphere is a symmetrical round shape. It is a three-dimensional solid that has all its surface point at equal distance from the center. Its surface point at equal distance from the center. It has surface area and volume based on its radius. It does not have any faces, corners, or edges. That is something that we are going to talk about later. Now, first of all, what is a sphere? We said a sphere is symmetrically round object. It is an object that is perfectly round. An example here, we have a ball which is perfectly round. This is a ball, but the center of the ball is here. So the center here is equal distance from the surface of the ball. Another example of that is going to be marbles. Another example of that is going to be marbles. They also have a perfectly round shape, and the center of the marble is equal distance from the surface of the marble. Like here, if you're going to take this ball to be a sphere, it has an equal distance from the center of the ball to the outside, that is the surface area of the ball. It is an equal distance. We look at the basic properties of a sphere. Although from the definition we are told that it does not have any faces, corners, or edges, so we will not stop there, but we will go further to find out if that is true, whether it doesn't have faces, edges, or corners. This we have here is a sphere, and from the center to the surface is the radius, which is r. So what we are saying in the definition is that from the center to any part of the surface is an equal distance, which is referred to as the radius. So we look at the number of faces that a sphere have. The number of faces that a sphere have. Now let's look at the sphere. How many faces does it have? How many faces does it have? Well, looking at it, it has just one surface area. It has one surface area, different from the face that we talk about when we are talking about the tetrahedron. Here is a flat face. Here we have a flat face, but if you come to spheres, they have only one surface area, which is a round surface area. The face is round, so it is just one face, one surface. Spheres have only one surface, because wherever you turn the ball, it is just one face that you see. So it has one surface. Spheres have one surface. They have only one surface. So when you talk about talking about faces on spheres, we only refer to it as a surface. It has only one surface. From there, we look at edges. What is an edge? We say edges are when two or more faces meet. Let's say when two faces meet, they form an edge. Now, since a sphere has only one surface, there it means it has no edge. There, in this case, we can say that a sphere don't have any edge. So even if you look at this ball, because it has only one surface and it is round, perfectly round, you cannot even have an edge. So the number of edges that it has is just 0 edges. It doesn't have any edge. And also we look at the number of vertices that it has. Now we say a vertex is where 3 or more faces meet, or 3 or more edges meet. Since it doesn't have a face, it has a round surface, and it doesn't have any edge, there it means it doesn't have a vertex. There is no way 2 or 3 edges can meet here while it doesn't even have an edge. So there also we can say it has 0 vertices. the ball or a sphere has 0 vertices. It doesn't have any edge, it doesn't have any vertex, and it has only one surface, that is one curved surface. It has one curved surface. So we look at an example, an exercise that is given to us here. It says write the name and properties of each of the figure in the table below. Write the name and properties of each of the figures in the table below. Now the first figure that we have is here, and the second one is also here. So looking at the figures, let's look at the first figure. What can we say about the first figure? Let's look at the number of sides that it has. The number of faces of 1. Here is another one, 2. Then the base 3, and the side at the back is 4. It has 4 faces. So, like, we can, by looking, we know that all the faces are equilateral triangles. So we can conclude that it is a tetrahedron. It is a tetrahedron. But let's see how many faces does it have. How many faces does it have? Like, this is how it is given to you. This is how it is given to you. You have 1 face here, 2 faces, 3 faces, and finally at the back we have 4 faces. So this tetrahedron has 4 faces. That is, the figure that we have has 4 faces. Now how many edges does it have? How many edges does it have? We have 1, 2, 3, 4, 5, and 6. So it has 6 edges. 6 edges. And how many vertices does it have? How many vertices does it have? We have 1, 2, 3, and 4. 1, 2, 3, 4. It has 4 vertices. Now from the two solid shapes that we talked about today, you can see that it's a tetrahedron that has 4 faces, 6 edges, and 4 vertices. So the correct answer here is going to be a It's going to be a tetrahedron. The name of the shape is a tetrahedron. From there we move to the next one, that is the second one. The second one has a round surface. Okay, let's say how many faces does it have? How many faces does it have? Well, it doesn't have a face, but it has a curved surface. It has a curved surface, just one curved surface. It has one curved surface. Now, how many edges does it have? How many edges? We say when 2 edges meet is when 2 faces meet is when we have an edge, when an edge is formed. So here, well, we don't have faces like where they can meet and form an edge. So there we can say it has 0 edges. From there we move to a vertex or vertices. We say when 3 or more faces meet, a vertex is formed, or when 3 or more edges meet, a vertex is formed. So since this shape, that is this plane shape, this 3-dimensional shape rather, don't have any edge, so we're going to talk about vertices here. So there it has 0 vertices. So what is the name of this shape? What is the name of this shape? It has one curved surface, one round curved surface. It doesn't have any edge and it doesn't have any vertex. Therefore, we can conclude that the name of this 3-dimensional shape, which is a solid shape, it is a sphere. The name, we can have it as a sphere, S-P-H-E-R-E. It is a sphere. With that, we come to the end of the lesson. I will leave you with a homework, and then you'll have to see exercise 3.3 and exercise 3.4 of the geometry worksheet in order to find your assignment. So I thank you all for your kind attention.